I'm Alan Davis, a software engineer, a former cardiac nurse, and a senior lecturer in health data sciences at the University of Manchester. My goal on this channel is to make health data science, AI, and digital health understandable for clinicians, researchers, and anyone else who's interested in learning about this technology. One of the most common questions that I often hear from clinicians is, do I really need to learn programming to do data science? And the answer isn't really a yes or a no. It really does depend on the role that you want to do, the problems that you want to solve, and how deeply you're interested in working with data. So in this video, I'm going to explain when programming is essential, when programming is something that will enhance what you do, and when you don't really need programming at all. I'm also going to talk about what I think clinicians should learn if they really do want to develop their digital and data skills. So you might wonder, is this question even important at all in the first place? Well, there's been an enormous growth in artificial intelligence recently, data science, digital health, and more clinicians are becoming interested in working in these areas. But I often hear concerns from people saying things like, I'm not technical, I hated maths, I'm too old to learn, and I'll never be as good as someone who's got a computer science degree. Also, before we go any further, I just want to point out that I'm going to use the terms programming and coding pretty interchangeably here. For the purposes of what I'm talking about today, they essentially mean the same thing. So in my time as an academic, I've taught many people of different ages and backgrounds, and it's often the people that don't have any previous programming experience that really surprise themselves the most. And I can give you a more concrete example of this. One of the modules that I teach involves taking people who have not necessarily programmed before, putting them into groups and getting them to work as agile teams. They follow something called the Scrum framework, where they have to produce an increment of work every couple of weeks. And we kind of throw them in the deep end. We expect them we give them some skeleton code for a dashboard. It has a web-based front end, a Python and SQL database back end, and they have to work on this skeleton code by adding features to it using the agile methodology. On top of that, we get them to do things like version control with Git and documentation, testing, and all sorts of other things. And I had a group that kept saying, some of the groups had some people in the group that had done some coding before. It really does vary. But one of the groups, complained that they didn't have any coders in their group, and they called themselves the no coding team. And when I saw their presentation at the end of the course, it blew me away how far they'd come essentially, and how they were talking like a seasoned development team without even realizing it. And I had to tell them, at the end, you can't keep calling yourselves the no-code team anymore, because you can code, you've got this far. So sometimes it's more of a perception thing. We're all learning, we're all still learning these things. Even people that have been software engineers for many years are constantly learning, constantly developing and enhancing their skills. So I guess maybe no one feels like they've completely got a full handle of this 100%, but these skills kind of build up incrementally, and it's surprising how you can learn these kind of things quickly and effectively by just working on projects and just getting that kind of experience. But that experience that I talked about really does reinforce something important, and that really is that learning to code is often as much about a mindset as it is any kind of technical ability. So I don't think you need to see yourself as a naturally technical person per se. You just have to be willing to take risks, make mistakes, experiment with things, and try to break things down and solve one problem at a time. So do all of these digital roles require programming then? The simple answer to that is no. There's a huge range of different roles and careers. Some require quite a lot of substantial programming knowledge and experience, while others require minimal or none. And in others, it's not essential or required, but it would be useful to have that ability, because it would enhance what you can offer. So the requirements can also vary between different organizations, even when job titles are similar. So some roles that might require little to no programming could include things like clinical informatics, digital project managers, product owners, digital transformation, information governance, implementation and adoption roles, and some NHS analyst positions. In these roles, understanding data and technology can be very important, but you might not need to write code yourself in these particular positions. It doesn't mean, however, that programming would be useless, because obviously if you can automate repetitive tasks, inspect data sets, communicate effectively with technical teams, and it can make you, more efficient and broaden what you can contribute to a group or to a project. There's also a lot now of visual or low to no code alternatives and tools that can allow people to do useful analytic and visualization tasks, even machine learning tasks, without you having to write a single line of code. The Orange data mining is one such tool that springs to mind. The other side of that, though, is although these tools can be really good for learning concepts, exploring data and developing prototypes, when you get onto projects where you need more control, reproducibility, automation and scalability, they can struggle and not hold their own with the same way that you could achieve having a fully fledged programming language. There obviously are also roles where programming is pretty essential. These include things like health data scientist, machine learning engineer, research software engineer, bioinformaticians, AI engineers and data engineers. All of those roles you're likely to need some level of programming or coding to do the job well. This might include using programming to do things like cleaning and transforming data sets, building statistical and machine learning models, automating analytical workflows, creating data processing pipelines and architecture, interacting with application programming interfaces, APIs, developing software or data-driven tools, and ensuring that work's reproducible. Visual tools can be useful for these things, but programming will give you much more flexibility and control over those tasks. So if you're a clinician, what should you learn? So the first thing is, don't try and learn everything all at once. It's going to be really difficult. A more realistic learning pathway might look something like this. You might start with some everyday data skills. So learn how data is organized, how it's cleaned, summarized and visualized. Look at things like data quality, the data quality dimensions, that sort of thing. And you can use tools and look at topics like spreadsheets. You could start with something like Excel. Basic data visualizations, understanding tables, variables and data types, and then introducing things like SQL for working with databases. And then you could pick one programming language to start learning about in more detail. For most clinicians that are interested in health data science, this is normally going to mean choosing between something like Python or R. So I would choose one in the first case, use it to complete some practical projects and examples, get comfortable with using it to solve real world problems, and then try to develop some supporting skills around that. So once you're comfortable with the basics, you can start learning topics like Git and version control, APIs, things like JSON and other data formats, testing and reproducible workflows, healthcare standards like FHIR. The exact order will depend on what you want to do. So someone interested in statistical research might follow a different path from someone who's, say, interested in developing software applications or machine learning systems. So I've worked in the past as a nurse in interventional cardiology. I've worked as a software engineer and app developer in industry, and a research software engineer at the university, and now as a senior lecturer in health data sciences. So in my experience, using programming across many of these particular roles, in my experience, programming is not the end goal, it's just a tool. It allows you to work with data more effectively, to test out ideas, to automate repetitive workflows, and answer clinical questions that might otherwise be difficult to investigate. Your clinical background in this case is not a disadvantage. It actually gives you a unique understanding of patients, of healthcare systems and clinical problems that many technically trained people just don't have. So the aim isn't to be competing with these people that spend their time and their career developing software. The aim is to contribute clinical knowledge with enough technical ability to solve meaningful healthcare problems. So do doctors and nurses need to learn to code? Not for every role, but if you want to work directly with data, directly in health data science, artificial intelligence, advanced analytics or software development, then programming is likely to become an essential skill for you. And even when it's not required, learning some programming could help you to communicate with technical colleagues, become more independent, and create opportunities that would otherwise remain closed to you. So you don't need to become a fully fledged software engineer overnight. Start with one language, one data set, one useful problem, and start building up your skills project by project. In the next video, I'm going to compare Python and R. These are two of the most widely used programming languages in data science. I'm going to look at what they're good at, how they're used in healthcare, and which one you should learn first. So if you are interested in learning to code, I've actually written some books on the topic, on learning to code and mathematics as well for clinical and health data sciences. So these are really written for people that are coming from a non-engineering and maths background, computer science background. They're for people coming from a health and social care background that haven't got that sort of formal mathematics and computing training that, you know, people that maybe come from that engineering sort of disciplines have. So it doesn't assume any prior knowledge and sort of starts with the fundamentals essentially. And the examples are in both Python and R, so you can pick which one of the two most popular languages for data science that you'd like to use. And if that's of interest to you, you can find links in the description below. Also, if you prefer something online, then I've got a free online short course in learning to code for people coming from healthcare background, also linked in the description. At the moment, this is just available in Python, but an R version is coming soon. In future videos, I'll discuss these roles in a bit more detail, as well as take a bit of a deeper dive into some of the technologies used and actually look at some examples of how we can apply some of these tools in practice.